Okay, thank you. So we're going to talk about mobile development in a post-continuous delivery world. And what I mean by post-continuous delivery world is the book's been out since 2010, so that's 5 years. And so we want to talk about how that's affected mobile and the projects that we're on, and hope that you guys can learn something from some of the drastic failures that we've made along the way, because failure is good because you learn from it. As we said, we are from ThoughtWorks. ThoughtWorks does custom software delivery from everything from mobile apps to Internet of Things, wearable devices, to just straight software architecture type stuff, which is a lot of my field. And ThoughtWorks is pretty much always hiring, so if you want to travel the world as a consultant, then come and see us after this. So, a quick foray into continuous delivery. Anyone not know what continuous delivery is? Okay, good, because I'm not going to explain it. Basically, they wrote this book quite a few years ago. This is something that ThoughtWorks had been doing for a long time. It's not just continuous integration about having a build pipeline. It's having a build pipeline that goes all the way into production. And this is something that I've been doing for probably like 6-7 years now, maybe even longer. So you might be surprised to hear that once upon a time, I told a client that they couldn't have continuous delivery. So let me tell you a story. Once upon a time, I was a happy software developer. Actually, I was much happier than I am now because I used to code a lot more than I do these days. And I thought I knew what continuous delivery was because, as I said, I was doing it on a lot of my projects, a lot of the practices of continuous delivery, and I was regularly releasing into production-like environments, automating my build pipeline, provisioning my infrastructure, lots and lots of automated tests. But one day, a client wanted continuous delivery. They read the book, they heard the benefits. They were on a 6-month release cycle, and every 6 months when they tried to do a release, they'd get the whole team in for the weekend. So they've got the analysts in, you've got the QAs, you've got the developers, you've got ops in, and it would take all weekend to do it. And sometimes it wouldn't work. So by the time we got there, I think it had been 3 weekends on the trot that the entire team had been in, so they were a little bit miffed. So they said, we would like that, please. And I said, okay. But 6 months later, they were basically saying to me, where is my continuous delivery? Just like a 5-year-old child on a car journey. Are we there yet?
So this is where, over beers one night, Rachel and I were talking about this, and I'm on my client site right now, and I'm looking at her and I'm saying, yeah, the clients are asking me for continuous delivery, and we're like, yeah, sure, we can do that. That was about 6 months ago, and I'm right at 6 months now, and I'm like, are we there yet? And so I'm looking at Rachel, and I'm like, oh gosh, we're not there. We're not even close to being there. And so let's talk about why.
What went wrong? Why could we not implement continuous delivery when we've been doing it for so long? Well, first of all, continuous delivery is actually quite big. A lot of people think it's continuous integration, which is just one small piece of it. You've got to automate all of these pieces as well. So you've got to have your environments up and running. You've got to automate your data schema changes. You've got to automate your configuration management. You need CI. In order to have CI, you have to have all the automated tests. And guess what? Before you even get started, in order to have any decent tests, you need a fairly good architecture. And on top of that, you need to be able to figure out how you're going to manage your releases, because it's a completely different game. And on top of that, if your organization isn't structured correctly, then it doesn't matter how much automation you do, you're going to be screwed. And so the lessons that we learned, and the reason that we got really burned many times and 6 months in still not able to do it, is basically because of the architecture, because it starts all the way back down when somebody first dreamed up how we're going to build this thing. And the thing about software architecture, and the thing that I learned, is this. So who's heard of Conway's law? There's a few people. Okay, I'm basically going to bang on about Conway's law for the rest of this session. Sorry. Conway's law, which I'll explain in great depth, is one of the reasons that you cannot do continuous delivery without thinking about your architecture and without thinking about the structure of your teams. And second to that, you also need to think about how are you going to evolve your architecture. So the idea that you can draw up your architecture at the start and expect that that's going to be okay in a few years' time, everyone knows that's a complete fallacy. So you have to know, okay, well, how am I going to be able to change my architecture? How do I keep changing these irreversible decisions that I make? And also, you only actually test your architecture when it goes into production. So let's start with Conway's law. This one's a fun one. So there's a very smart guy called Melvin Conway who wrote about this, I think, in the 60s. And we've still not quite figured it out yet. He basically said that however you design your team structures is basically what your software will look like. And the way that I see this play out most often is like this. The monolith. Anyone have one of these? Come on, I know you do. Even if you guys are the mobile specialists up here at the top, I know you're consuming this. So you've got all these DBAs or some kind of data layer, and you've got some kind of service layer, and you've got some teams at the top who have to consume all this. And the reason that this sucks for continuous delivery is because if you want to rapidly release into production, and you're the guy at the top, you're still got to wait for all these guys to get their stuff together. And it hurts. It takes time. And there's another thing that Melvin Conway actually says in his paper, is that the first design of the system is basically not the best. This is when you know the least. So if you've ever been through a code retreat, this is a session that they have quite regularly where you kind of get to hone your development skills. I highly recommend it if you've never been to one because it's a lot of fun. And basically you're working on just one simple problem, the game of life problem. You spend like 40 minutes in a pair coding up the problem, and then you get together as a group afterwards and talk about the solution. And based on what you guys learn, you then throw it away and start again. And you do this like 6 times. And by the end of it, I was even surprised by how good my design was. I thought I was a pretty good coder. I was like, wow, this is awesome. But in real life, how many times do you get to design your system 6 times? Not usually on purpose. You've done something wrong, probably, if you did. Not many project managers I've ever met have said, sure, just keep doing that until you get it right. It doesn't work like that. So you have to design your system in a way that's fairly flexible to change it in the future. So here I'm going to talk about the wrong side of Conway's law. And this is actually usually the side I'm on when I'm going into client sites, because when we go in there, something's wrong, and they need help with something, especially like getting continuous delivery. They want that, all of these things. So using the example of the client that I'm on right now, it's a financial institution. And so when we go into clients, we usually see this architecture. Pretty sure everyone recognizes this. It's the tiered architecture. So we have, as Rachel's talking about, our user interface. So that's all of our native apps and web apps. And then in the middle is the business logic and all the rules. So that's where all the crux of the logic lies. And then you have your databases at the end, right? And so in this type of architecture, usually the teams are corralling around these different areas here. And so all of the mobile developers are at the top here, and they're all in one corner. And then you have everyone in the business logic all in another building. And then we have all of our database people probably in the basement, right? So they're all kind of just talking to each other, but probably not talking within each other. Those are the grumpiest guys, the ones at the bottom. Everyone wants something from them.
So yeah, so as Rachel was saying, this is maybe not the type of architecture that is conducive for continuous delivery. So for continuous delivery and rapid release, we need to be able to, bang out these changes really quickly. But if no one's really talking to each other, this architecture might not be the best way, right? So going into my client, what we did was we looked at what we talked about earlier, architecture. Let's look at the current state of architecture of the current client that I'm in right now. So I'll take you through this really quick. So this is shared services. So this is where all the crux of the logic lies. Like, so with this financial institution, we talk about payments and we talk about statements and rewards and all of those things. And so all of that logic lies here. So this is what they build everything on when they started, right? And so, of course, we have our web applications. So we have all of these different clients that are talking to these shared services, and everything's hunky-dory. We're all very happy about life. Everything's working. And there's so many animations. It's awesome.
This is actually one of the reasons people love this monolith architecture, because it actually gets you up and running really, really quickly.
Right.
But as it gets bigger and bigger, it starts to kind of get cruft.
Yes. So this shared services and all these clients that are consuming this has been going on for many, many, many years. And so this is a very big financial institution. A couple years ago, they said, oh my gosh, mobile is huge now. We need to create an Android app and an iOS native app. Okay, that sounds great. So why don't we just create those two apps and then have it talk to shared services? Wrong. So what happened is that we have, for example, payments and rewards. And so if I make a payment and I actually want to get some rewards out of it, I have to make about 4 or 5 different calls to this shared services. And as you guys know, from a mobile app, making that many network calls is insane, right? You'll never get anywhere. Your payment's not going anywhere. So what their solution was, which I'm not saying was a bad solution, was to create a mobile service. Animate. Yes. Mobile service that actually talks to the shared services. So it consumes all of those different network calls. And now my Android app and my iOS app only needs to make 1 call to this mobile services. Yeah, all right, that sounds good, I think. But then they called us in. Why?
What's the problem with
what are the problems you see with this type of infrastructure? Latency? Yes. Too many arrows. Yes, who said that? Who gets a point for that game that we do? We get 5 points to that guy. Yes, too many arrows, right? So the dependencies are crazy right now. And if we look at this, in this client, each team, there's a team for each one of these boxes, right? So as I'm talking earlier about the silos that are happening, there are already silos for, we have a team for shared services who actually work in one building. We have all the clients that say, oh yeah, I'm this web and I'm this web, and we're our own teams. And then now what they did was they created a team just for mobile services, just to consume the shared services and send those out. Then there's an iOS team that only does iOS, and then there's an Android team that only does Android. So the problem that we see here is that when we have different teams like this, we have different product owners, we have different requirements, different prioritizations, right? So for example, if someone from up above says, I want this X, Y, and Z feature on iOS, then that's a priority on iOS right now. Okay, so then let's develop that. But then we need something from mobile services. Well, their priority is not that right now. They have to deal with something else, something on Android or something like that. So what happens is we start duplicating code. We start implementing that business logic up in iOS because we need to bang out these features. We have deadlines. We have to figure this out. So all of a sudden, I'm seeing duplication in iOS code and in Android code, and then something happens in mobile services, there's probably duplication between that and shared services. So these are big problems because these teams are not talking to each other. They have different goals. They have different priorities. So what do we come up to?
my favorite software architecture pattern? Or it's actually, I'm joking, it's obviously not my favorite, but it is the most common software architecture pattern out there. It's called the ball of mud. And to prove a point, I've actually created many of these in diagrams over the years using various tools. This is a real dependency diagram, by the way. This one was cyclic, and the downloadable tools wouldn't run it, so the team wrote their own tool to figure out the dependencies. That's serious yak shaving. Anyway, the point is, even if you're not in this sorry state, usually you've got some ball of mud somewhere, and that will stop you from releasing rapidly, because every time you want to make a change, someone's going to have to run like a shed load of regressions across every different app that's pointing everywhere, and everything just takes forever, and something always breaks. And in this particular instance, this was the client that was like, where is my continuous delivery? And I said to them, well, actually, I didn't, but I wish I could have, because I'm a consultant, so you can't say exactly what you're thinking. But I was like, where is your architecture? Seriously. You don't get toys like continuous delivery if you do things like this. So, and this is caused by, this is the paper, by the way, if you want to read about the ball of mud pattern, by Brian Foote and Joseph Yoder. It's caused by expediency over design. And this is a very common problem. Even if you design at the very start, when you've got deadlines and things need to happen, you just get moving. You get moving quickly. And over time, you amass technical debt. And everyone's like, oh, everyone's got technical debt. We'll fix it later. Later never comes. But there are different types of technical debt. So there's the technical debt where you're like, we've just got to get out the door and we promise we'll come and fix it later. And then there's just completely reckless, like, I don't even have time to design this. And the more reckless it is, the worse it'll probably be. But regardless of where you are in the quadrant of technical debt, you have to start tackling it.
So yeah, I mean, so the client that I was talking about earlier is more in the prudent quadrant right now. So I said earlier is that they just wanted to bang out features. And that makes sense, right? So from a financial institution, they have competitors. They need to get this mobile app out right now. They need to get all of the features running, and they need to stay above it to stay competitive. But the problem here is to deal with those consequences. When are they going to deal with this later? And so now that we want continuous delivery, we're going to have to deal with these consequences much earlier. So that's what we're going to talk about.
And technical debt really all boils down to coupling. It's all of these problems just boil down to coupling, whether it's who's consuming my artifact or how many different services I need to consume. Every level of coupling that you add to your system slows you down, creates a dependency, and makes it harder and harder to do things like continuous delivery. And we know that, you know, we need to reduce coupling. It's a well-known fact that when you're a good software architect, a good designer, a good coder should always be thinking about, you know, I want low-coupled systems, and I want them to be highly cohesive, highly robust, highly reliable. And you're like, cool, that's what I want, but this is actually really, really hard.
So going back to my favorite client, of course, they all look like this, by the way, so it's not, you know, I'm not just picking on this one, but going back to the cohesion and the coupling. So now we can see, like, on top of all the duplication that I talked about earlier, we have this coupling between especially shared services and mobile services. So something that happened a month ago was a business requirement came in from one of these web clients and said, we need to do X, Y, and Z, so this endpoint over here needs to change in shared services. Sure, that sounds great, we can do that. Let's put it on our priority list and let's bang that out. So that happened, and this endpoint changed here. But they didn't really tell anyone about it up in the mobile land because they're just mobile people, who cares about them, right? We need to get this out here. Has that ever happened to anyone? Someone changed an endpoint on you? Ah, there it is.
Finally, a show of hands.
Ooh, I was like, wow, we're not the only people dealing with this, right? So yes, an endpoint change, and all of a sudden, the iOS and Android app failed in production on one of the calls. And we're like, what? What is going on? And essentially what happened was they changed like an int to a long or something crazy like that, right? And mobile services wasn't able to consume it, and all of a sudden, that endpoint went down. And we couldn't, and now we have a huge production issue. Right? So this is precisely why continuous delivery is hard if you change something from an int to a long and then you cause a massive issue in production. I mean, that's huge. So, yep.
Okay, so it's a sad story tale. Here's one I made earlier as well, another dependency diagram. What do you do with this? How do you get yourself out of this mess? How do you start to untangle it? Because we've all got, you know, these brownfields, as people like to call them. So the first thing is that I like to think of, and because a long time ago people would get into these ball of muds and they'd be like, do you know what, this is a mess, let's rewrite the whole system. And we all know how that went. A lot of those companies went bust, Netscape. So that's not the way you would need to approach it. We like to follow the 80-20 rule, right? So what you discover, and especially if you have decent metrics, is that probably your customers and users are only using like a 20% of your features very heavily. And those are the ones that you need to untangle. Those are the ones that you care about. And so you need to look at things like, what are the chunks of functionality? And for those chunks of functionality that you really care about, how do we figure out what the coupling is there? How do we uncouple them? Think about where the software is going. So what are the demands that the business is asking? Like what new features are they after? Let's start picking up those pieces. And look at the life cycle of the code, right? So just because this one thing I really hate is the idea of this one true customer that the DBAs came up with once upon a time, because it's a living nightmare if you've got several different apps that are all doing different things with one true customer. Because the life cycle of that customer, the data life cycle, is very different in different contexts. And so you need to start breaking up things like that. And things like domain-driven design really talks about how you do that. But one thing to focus on is metrics. So this is a heat map from a previous client. The black ones are bad, by the way. The white ones, good. you'll be unsurprised to know that the 5 main features of the application are all black, because that's where everyone's constantly changing code and just adding more and more functionality and logic to, because that's basically, those black pieces essentially run the application. And this is basically toxicity. This is like how cyclomatically complex is my code. And then you also look at things like churn. How often are things changing? So if you're using Git, which most people these are, you can just run a really simple command to find out how often, which of the files that change the most. Yeah. It's very straightforward. You look at all these metrics, plus where their business is going, and start breaking things up. And the other metric that I use, which is qualitative, not quantitative, is I go around asking the developers, which piece of the code are they terrified of changing? And that's usually the black ones. I've never been wrong. I'm like, my metrics, they're always right. But if you want to start tackling this problem, and you do have these problems, a good book to read is obviously Michael Feather's Working Effectively with Legacy Code, where he talks about how to kind of attack these different pieces.
So that metric diagram that Rachel just showed was actually from the client that I'm on right now. So she pretty much went there, did that toxicity report, and then left me there to dry. So thank you, Rachel, for that. But at least she's talking to me about what can we do. So the one thing that we're starting right now is a strangler pattern. Who's heard of that? Everyone's, no, cool. Then I can talk a little bit more about this. So the strangler pattern is what we're going to use, or starting to use, when we start up here with this existing monolithic application. So that's the shared services that you see that's been there for like 10 years, and it's huge. All of those black spots in that metric diagram, it's very complex, right? And so how do we start getting this to be not as tangly, or how do we untangle this? And so what we would want to do is actually, first of all, start putting up some functional testing around your business logic. So what Rachel mentioned earlier was, where is that core functionality that everyone's using that we don't want to break in production, right? So in this example, our biggest thing is payments. We want to get paid, right? So that's actually a big business requirement. So one of the things that we did is that we took that payments piece and started writing these functional tests around it, right? They're a bit brittle, but at least we have some sort of safety net saying we're not breaking this piece of functionality. So after we do something like that, then we start breaking out the new modules. We start pulling them out and actually testing them by unit tests, making sure that each of these modules are tested by, JUnit, all of those things that we want to break this out into. And then eventually, when we start doing this, we can actually start untangling all of the code and actually creating all of these new modules. And now, all of a sudden, you'll see all these modules popping up, and we're slowly untangling that ball of code that we don't like and are very scared of.
And it's important not to just write the new module kind of exactly like the old one with tests, which is a common thing to do. You actually start thinking about the life cycle and context of things. So payments is a big ball of mud, right? But there's obviously different types of payments with different types of users and different types of customers, and that's what you're actually going to start breaking up.
Yep. So in terms of mobile, talk a little bit about testing. If it transitions from my phone. Testing in the mobile world. So this is again, I'm still using this client, picking on them a lot. When we went in there, we actually had to see how much tests they had before we start untangling this. You never ever want to untangle code when you are not testing it at all, because it's all going to change and it's all going to break. So if you look up here, it's actually at 13.7% of lines of code that are covered. So 13 is actually pretty good for this client. There are some clients that I go to and they're 0%. They're like, what is a test? I don't know what tests are, which is terrifying, right? So this is actually one of the metrics that we ran on this code base, because we wanted to know how can we start pulling out into these different modules. Well, we can't yet. We have to figure out the coverage of testing so we don't break anything. And then the next thing that we did was we introduced tests to them. So everyone knows about this, test driving iOS development with Kiwi. So this is an iOS testing framework, BDD framework, which test your iOS code and make sure that you're covered on that. The other one is RoboElectric for Android. So this is something that we also introduced to them. They were like, oh, we can't test these activities and life cycles. I'm like, dude, you can. there's something out there, man. So the other thing that we've used was Appium and Calabash, and that's the functional testing framework that we use in order to make sure that the business requirements are still there, right? We have that flow that these are run on real devices, so we can make sure that these are definitely not breaking anything when we start changing this code. And then the last bit is actually putting it into continuous integration, right? So these tools are quite new still. Mobile is still new. All of these things are open source. They're still being worked on right now to make them a lot more stable. How can we rely on these testing frameworks if we don't keep contributing to them? So we were talking about earlier that open source is huge. We love open source. ThoughtWorks in love with open source. So I urge you guys to keep looking at these different tools and making them better, because we want them to be able to test all of our code and make sure that they're reliable. And then integrating that with CI so we have those gates that stop us when we actually do break something.
So, how do we get Conway's law on our side? We've got into a bit of a mess. We've accepted that it is what it is, and we need to get Conway's law on our side. But you can use it to your advantage, which is nice. So, anyone read Release It? If you are doing continuous delivery or thinking about it, this is a serious book to read, because Michael Nygaard talks about basically how you keep your production, how you architect for production. It's an awesome book, talks about how you make sure, how you scale, how you make sure things don't fall over. And even he talks about that the team design is the first draft of your architecture. So when you've got the opportunity to readdress your architecture, you actually just need to look at your teams. So I'll take you back to another, this is a client from a few years ago actually, and they had a real estate application. And this application served many different countries, and so basically had many different product owners, and they had many different apps. But they'd all, at some point in their past, decided that they would all share the database and the services and all that kind of thing. And it was extremely painful, and they couldn't get releases out to production, and somebody would change something and everything would break. And so the first thing that they did is they created vertical teams. So instead of having these siloed teams, they decided to cut the teams down the middle and have teams that are responsible for business capability. Oop, I bounced too far, I apologize. Called the inverse Conway maneuver, which is what Martin Fowler talks about. So here we've got cross-functional teams. We've got everybody we need in the team for the particular product and context, and they're organized around the business capabilities. And so what these teams decided to do was they decided to fork the code base and say, right, let's just fork it and make our own. And we can then deploy independently and get things out the door. And then they created affinity groups so that they could talk to each other about what they wanted to share, because they were very careful about sharing because they get burned so many times by it. So what they wanted to create is shared libraries and shared services, and the rest of it the teams basically built on their own. And I'm sure people have heard about microservices. It's the latest buzzword, but it's basically just SOA done right. Is they eventually had microservices. And one of the things that they did was keep the teams small. So this whole, everyone's heard about it, Amazon, pizza teams, keep your teams small to keep the context. But the problem is it's not as straightforward as that. When you've got just purely product-facing teams, you've got to think about, well, who owns the system, and how do we make sure that we're not duplicating code everywhere in the wrong way, and how do we make sure that we've got eventual consistency and all these kinds of things. So there's a lot of different ways that people do this. If you read about how Spotify does it, they have these tribes and chapters and guilds. And this particular client, what we had was a rotation model. So we had all these product teams, and we had anchors in those teams, and then people would every so often rotate through teams so people got an understanding of the teams that they depended on and things that were around them.
So we took this idea, and now we're going to apply it to our client right now. And this is actually something that we're doing. So when I talked earlier about modularizing, say, payments, for instance, instead of just saying, hey, let's just go modularize it, we actually created these teams. So we took this organization, and they had their iOS developers here, their Android developers here, and their services people here. And what we did is we plucked 2 iOS people here, 2 Android people here, 2 services here, and actually started forming teams more around the features themselves. So as I said before, we have payments, statements, and rewards as an example. And so now these teams are cross-functional, right? So we have our iOS, Android developers here, and our services here. So what do we get here? We get feature parity now. So now that if something changes on the services side for the payments, the people on the same team know about it, right? The Android and the iOS developers know about it. And so they can actually create that feature together. And the best part about this is that these developers, we're starting to see them become a lot more polyglot now, right? So we have iOS, Android services people pairing together, trying to understand what each other are doing and writing the code at the same time. So some of these developers came up to me and they're like, "Oh, I know Android now. I've always been an iOS developer. Oh my gosh!" So this is a good resume builder too if you want to expand your knowledge.
So, to wrap up Conway's law, it's all about coupling, right? At the end of the day, even if you go down the model which Cassie's describing, those teams are still coupled to each other. There's still some data that they need to share, and you cannot get away from it. But you have to strive for as low coupling as possible. So, in order to get continuous delivery and for all these different teams to get their stuff out the door and orchestrate that together, you want to strive for as little coupling as you possibly can to get deployment independence. Because the more coupling you have, the more opportunity you have to break each other's builds, and everyone hates that.
Don't break my build.
Yes. The other final thing I'll say about Conway's law is what we've noticed that more and more teams are doing as they adapt these models is the whole idea of projects is kind of getting thrown out the window. Because the problem is that with projects, the team dies and then it sits in production and the operations guys have to keep it alive forever, even though they've got no idea what you built or why you built it. But with products, when you're all focused on a product, it stays alive. Even if there's not lots and lots of happening in payments right now, there's going to be something, and someone's keeping hold of it and having ownership of it and making sure that it doesn't turn into a huge ball of mud. And so basically, continuous delivery and lean development practices really do go completely hand in hand.
And one thing about this is the product is very, very important. I've seen now that on the teams, there's a bunch of team ownership now, because it's not like, oh, I'm on just this project. It's like, no, I'm on the payments product right now. And that when you see that in production, you sort of own that as a developer, as a QA, as anybody on that team, because you're actually owning that product itself. I think the theme of this entire conference is thinking about your customers, right? Thinking about the product that's going in front of your customers. So this is something that we want to go not just from the product owners, but all the way down to your developers saying, this piece of code is going to create this product that the customers are going to see. This is very important.
So we've talked about designing your teams, but I haven't really covered some of the really hard pieces of how do you evolve your architecture, right? How do you make decisions about things that are hard to change later? And because we know that big design up front didn't really work out for us, and so then people went agile and just stopped designing altogether, which was terrible idea. And so there's got to be somewhere, there's got to be a middle ground, right? And so Neil Ford, another thought worker, he wrote about this in an IBM series about evolutionary architecture and emergent design. And I'm going to talk about the hard piece, because emergent design is really just about, hey, TDD your code, write some tests, have some decent abstractions, use things like dependency injection, don't be dumb, basically. And then you'll be able to emerge your design. But evolutionary architecture, it can't emerge. You've got to make some decisions. You're like, okay, security, it's very hard to think about that later when you've been hacked and you're in a lot of trouble. You don't want that to happen. And so what you have to do is think about, like, what do you need to decide now and what do you need to decide later? So there's a few principles of evolutionary architecture which we'll try and run through now. Okay. Anyone played Lemmings? Yay! Okay, awesome. This is my favorite game as a child. And sorry about the quality, but I actually think this is what it used to look like. So when you first start playing Lemmings, all of the lemmings come out of the door and they fall off the cliff or whatever it is that they do, and they all die, and you're like, oh my god, what do I do? And the reason they do that is because you're trying to, like, you see that these people have got skills and you're trying to deploy them all over the place, and you're just trying to do everything at once, and everything falls apart. And so you can learn something from Lemmings, because when you get good at this game, you start to figure out how to deploy these different lemmings and their superpowers. So at first, the first thing you need to do is stop all the lemmings from dying. So you just put some kind of barrier in the way, and then you set off your superpower lemmings to build a bridge or dig a hole or whatever it needs to be to let the lemmings through. And then eventually you let all the rest of the lemmings through. So how does this apply to evolutionary architecture other than Rachel just likes talking about computer games? It's really about don't burden yourself with everything. So one of the things that they used to do, architects in their ivory tower, creating amazing designs, was try and fix everything, right? So I'm going to figure out how it's going to scale and secure and performance and hardware and what kind of devices, and I'm going to think about everything all at once now, and then everyone's going to live with my decisions forever and ever till the end of time, until someone rewrites the application because it's a mess. And so the last responsible moment, which is a principle of evolutionary architecture, is the idea of, well, what do you need to know about now? Like, what are some of the decisions that you actually have to think about now? And make decisions on those. This has one exception. There are certain things your software should never do. For example, crash, hang, lose data, violate privacy, lose money, destroy your company, or kill your customers. If you're doing that, you're doing something wrong. Yeah. But other than that, there's a bunch of other things that are, okay, we'll do this now and we'll do some things later.
So many things to consider in mobile, let's tie this back, is, yeah, these are things that we want to consider. So scalability, network, devices and hardware, usability, security, these are all the things that we want to keep at the top of our mind, but that doesn't necessarily mean that we have to fix these problems right now. So as Rachel said, we should do this just in time.
And we call this is the next principle, we call this architecting for evolvability. So this is my crystal ball. So as a technical lead and software architect or whatever label they put on my head that day, I have to look into the crystal ball and figure out what's going to happen in the future. But there are certain things that you can kind of just figure out, right? So if no one's ever used your application before ever, then designing for scale, that might not be a great idea, because you're going to probably design all these different components, that this will be up at this time and I can do failovers and all this kind of stuff. That's a lot of thinking and doing before anyone's even downloaded your app. So there are certain things that you can account for. And the other thing that I want to point out, so I kind of hit on legacy. I was giving it a hard time a minute ago, or 10 minutes ago. But in every other field, legacy is a good thing, right? In music and art and all these things. If your software has made it into production and everyone freaking loves it, but it looks like death underneath, that's actually a good thing, right? You've done well. But now you need to make it better. Now you need to learn your lessons and say, okay, we've figured out where it's at. Now we actually need to scale. So let's fix that problem.
So how do we evolve for evolution, right? So let's go back to this metrics slide. But this is actually where we start, right? So we have to look at our code base and we have to see what is our pain points right now. So if that black box is all around our security, maybe this is something that we need to look into and do right now. But maybe the white boxes are around scalability and this code is not that complex, so we can scale this up. Then we don't have to think about scalability in that sense. So metrics is going to be your best friend when you actually want to think about where you want to focus the just-in-time. Where do you want to focus, spending your time, scalability, security, all of those things, all the ilities. So a few examples of what we want to think about is multiple platforms and devices. So I don't have to talk about this in depth. I think we've all had the pain points of developing for all these different types of iOS tablets and phones. And actually, they're actually not that bad, because they do this fun thing of force upgrading you. If your app doesn't support this, so that's actually kind of good in this sense. But Android is a little different. I don't know, who knows the number of how many APIs and devices and all of that stuff is out there? A lot, right? So one of the things that we want to think about here is, who's your customer? And when we use those metrics and we use things like, when my transition comes, metrics like this about who your users are and what type of devices they're using, what type of APIs are they using. From a financial institution, maybe my customers are all Android users and maybe 20% of them are iOS. So I'm going to focus on the Android portion and not the iOS, right? So metrics is going to be your best friends when you're actually trying to target what you want to focus on, so you don't have to think about all of those things that were on the list earlier all at once. The other thing to think about is, what kind of features do you guys want to focus on as well? Right? So everybody knows what feature toggles are, correct? Yeah? kind of. All right. So this is a blip from Martin Fowler's blog around feature toggle. So very quickly, because we're running a little bit out of time, if you want to show one thing and then and not the other, then you can actually feature toggle that on and off. So this is actually an example from, say, a web app. I'm going to skip over really quickly to how we would do it in native apps. So here, it's just a very quick example of like a hello world in your iPad. If you have an original feature called old hello world, and you want to actually test out your new hello world feature in your storyboard, you can actually do a feature toggle in here and have your configuration in your plist here. Okay, so this is actually a good way of doing A/B testing, seeing if a feature is actually good in production, if that's actually being used, and you have the metrics behind to show, like, are the users actually using it? Are they going to that one particular feature a lot? So one thing that we've actually dealt with on different clients is how do we do feature toggling in native apps? I mean, that's actually kind of hard because we have this deployment cycle into the app stores that have a bit of a time lag. So for iOS, I mean, it could be days, it could be weeks before your app gets into production. And then Android's a little bit better with Google Play. So one thing that we did do with the feature toggling is make it a server-side feature toggle. So what we would do is have the configurations set up in the iOS and Android native apps and deploy them with the different features that you want to toggle between. But when the user launches that app, they actually are going to make this server call to the service and actually grab like whatever feature we want them to look at that moment. This is actually very useful, especially like if you're in production and you have a feature that may have a bug, and instead of having to build a binary very quickly and say, App Store, please accept this so I don't lose money on this bug that we have, we can actually change the feature toggle and turn it off in the service right away, deploy that right away, and then when the user loads up their app again, they don't see that feature anymore. This is pretty important. So just going back to that deployment, so this is something that everyone knows that iOS say is they're going towards continuous delivery a little bit more. So we're a little bit behind still, but at least now from the CI pipeline, we can actually, build our code, run all the tests, and actually using TestFlight, push up the binaries to the iTunes Connect store. So the one last piece would be just clicking on that one binary we want to use in order to submit to the App Store itself. But at least we're getting closer. This wasn't here a year ago, right? So this is it's progress. We like progress. So the next thing, really quickly, is architecting for testability. So we talked about architecting for evolution, but let's talk about testability. So all of these things I talked about earlier, like we want to cover our code and make sure we're doing this. We should be doing this from the get-go, making sure that everything is tested from the minute we start our apps.
So the last principle of evolutionary architecture I want to talk about is Conway's law, right? So if you remember very little else from what Cassie and I have been talking about, then remember that however you design your teams is really how your architecture look like. And so it's really all about people. And so in 2014, Puppet Labs and ThoughtWorks did a survey of hundreds and hundreds of customers and asked them, what made their organization perform well. And these were the things that came back. So it's a competitive advantage, shock horror, but DevOps practices really improve IT performance. So doing a lot of the things that we've been talking about will actually improve the performance of your organization. But what else came out is that culture really matters, and job satisfaction is a real indicator in terms of like organization performance. And so when people aren't spending all weekend trying to deploy or stressed out begging the App Store to let their apps in and implementing some of the practices and methodologies and techniques we've talked about, then they tend to be a lot happier in my experience. So usually by the time ThoughtWorks is brought into a client, everyone's very sad face. And usually by the time we leave, they're kind of like, we don't need you guys around anymore. What are you still doing here? And that's really our goal.
That's good.
But now that we've shared all these secrets with you, as they say, with great power comes, great responsibility. So there's nothing to say you won't end up back where you were at before. So you have to keep thinking about the coupling, about the team design. You can't just set off on one journey and be like, right, we'll restructure all the teams like this. They'll design everything themselves, and let's just leave them to it. See you later. We're good. What I've learned in my career is that you have to keep on top of these things. So even the shining lights of Spotify and all their amazing models and Amazon, they have to keep on top of what they're doing. They still have problems. They still have dependency problems. They still have bad code. Everyone still has these problems. And if you don't keep on top of that technical debt, you basically end up where you were before, but it'll just look different and it'll be a different tool stack. So the lessons that we've learned in the web world. So for many years, people have been like, we're mobile, we're different, we're mobile, we're different. And what we're trying to say here is, no, we're not different, actually. In fact, we've got even more constraints. It's actually even harder for mobile than it was for the web. And that was harder than desktop apps. And so you actually need to be more mature than the web people. You need to get better, not be behind. So as Cassie was saying, contribute to the open source tools, make this a better place to work so that you guys don't end up, well, calling us in a few years' time, crying after spending weekend after weekend after weekend at work. Unfortunately, as always, there is no silver bullet. But I'll leave you with some awesome Michael Nygaard quotes. Hope is not a design method. I promise you it doesn't work. Conway's law is the law. Evolve your architecture. And my favorite, if you fail to design for production, your life will be filled with excitement and not the good kind. Thank you.
Thank you very much, ladies. It was a great presentation. Could you please tell us more about... I have a first question. Just stick around and the mic will be passed on to you. I have a first question. The first question is, as far as I remember, the Apple guidelines forbids shipping application with the hidden features. How this relates to the feature toggles like you mentioned before?
So yes, that's that's actually what we're having to deal with right now. So the way we actually, it's not actually hidden features. I mean, you're still developing the storyboards the way it's supposed to develop, and I mean, yes, we'll probably have to deal with some problems in the future, but this is very new, the way that we're doing the server-side feature toggles. So I'll let you guys know, but it's not like you want to just hide a certain UI or hide this and that. It's actually an architecture where you are using your plist to look at the different storyboards or look at the different using a strategy pattern or something like that. So, yep.
Okay, so we have a time for two very short questions, and that will be it. Anybody?
Okay. You said that you go to the customer which is sad and then he is happy. How long does it take to make him happy?
I'm going to give you the consulting answer, which is it depends, because it depends how much of a mess they're in to start with. So that one, my client, this was years ago, and we're still there helping them because that was huge, a huge mess. We've been at your client now I went there in like April. So it usually, if they're in a big mess, then it can take like over 6 months, maybe a year, maybe 2 years, but it really depends where they're at.
Yeah, it definitely depends. So at this point in time, I'm glad that I've been talking to Rachel about these types of things because we're trying to get ahead of it before it becomes that massive ball of mud. It's kind of like a mini ball of mud right now that we're trying to decouple. And then so they don't get into this and it doesn't take as long to stay there and decouple all that stuff.
Okay, let's have another quick question and then we will move towards another talk. So, anybody? There isn't a question. Okay, thank you very much, ladies. It was a great talk.
Thank you.
And have a great night today.